Okay, so first thing we're going to do is go to microsoftmakecode.org, head to Microbit, and in here you can make a new one called whatever you want to call it, but I'm going to call it Data Collect Micro for my Microbit. And I'm going to create it. So what I want to do is I want to collect data. So first thing I need to do is I need to go down to serial and select serial redirect to USB. That'll allow us to send signal down the Microbit cable. Next thing I need to do is send some data. So I've got choices. I could do light level or compass or temperature. I'll go for light level because I can change that pretty easily. So back in serial, I need to select serial write line or write value. I'll go for write line right now just to show it. So I'm going to write the line there. And the next thing you need to do is connect up your Microbit. So I'm going to grab my Microbit and I'm going to plug it in. So as it's connecting here, might have just connected straight away, I think, because I've plugged it in before. Let's just see. So it's giving zeros when I go to show data, and when I shine a light, hey, there it goes. Now I downloaded this program previously, so just make sure again that you download it, right? But there's two, show data simulator. Now that's going to just show 128 because that's over here, and you can adjust that number here. This is just a simulator, so this is not actually happening on the Microbit. Whereas this one, show data device, you can see it's giving 000, and I've got a torch in my hand, and as I shine it over, it's jumping up there to almost 255 and then going down. So I'm just shining a light further and closer away there to really adjust and play with it. Okay, so that's one thing we can write. Now the other thing we could also add to that would maybe be, let's take a bit more detail and let's also add in a little pause. So we're not just doing like a billion readings because we don't want to fill up a file. So we might do a reading every second. I'll also go crazy. I could have done this serial write value and put the value as light and then get rid of the serial write line. And now when I download it, let's just have a little sample. If I go to show device, it's now going to say the word light and then what the value is. Okay, so adding to this now, we can also add in to say do temperature. So I'll just duplicate this, get rid of that. And underneath, I'm going to do it for temperature. So I'll say temp, temp, and I'll do just the built-in. Obviously you can connect external devices. It works the exact same, except you'll pick your serial pin, the appropriate one. I'll do that in a separate video. So here's the one is going to send the light. Now Steve did not download. Always remember to download. So now it's sending both light and temperature. Okay, every second it sends one, and then another second it sends the next. Okay, so that's us now. We've set it up that it is collecting data. So the next thing we need to do is create our Thonny code to analyze that data. Okay, so here we have, let's take a look. We're going to start creating our Thonny file to analyze our data. So the first thing I'm going to do is import serial. That's needed to connect so we can actually just take data from the serial port. I'm going to add these next few lines. I'm copying and pasting from another bit, but just so I can talk through them as I go. So we're going to update the serial from the Microbit. So this shortens serial, the function, basically just to be sir. And we need to have the correct signal coming in. So this seems to be the correct one for most Microbit computer things. You can Google it if that's causing you a problem, but so far it's caused me 0 problems. And then we need to connect to the right port. So these first couple of lines are all necessary. So in order to connect to the right serial port, you need to go into your search and type device manager. And in there, I have it here just as COM3, but I'm going to go to ports. There, make sure your Microbit's plugged in or it won't appear, right? And you'll see US serial device, and it's actually COM4. So what I need to do is change this 3 to a 4. Okay, it'll be different on your one, and if you move it around the different USB ports, you're going to get something different. Now, next part, I'll just drop this all together, is we're going to do the following. Okay, so first we're going to print, just say type Control-C safely exits. That's how we exit taking the data. And we're going to open the serial port. Okay, so this means I'm opening it now and I'm ready to collect data. So while this is happening, I've created a try except here, right? So basically, first off, the try except is allowing for if there's any blank inputs, right? But if there is, it'll just pass it. So it won't break our code, right? So while it's here, it's going to read the line, so serial read line, and it's going to read it as a string, and it's going to save it to a variable called measurement, and it's just going to print that measurement for me. And then the keyboard interrupt, that's Control and C, this business earlier, will print a little message saying, hey, we're closing it, and then it'll safely close it, okay? That'll stop it from screwing up your data later on in your file when we go to save it. So let me just try run this current script. So it's type Control C to safely exit. That looks good. And then nothing seems to be happening. So I'm just going to go in and check. Oh, I know what might be going wrong. No, I don't. So what probably it is more than likely is COM port 4. So I'll just stop the code. There we go. And I'll go back to my device manager and just double check. Oh, was I in the wrong one? Port maybe. Let me go to you. No, okay, we'll go back to your ports. I'm going to try port 1. Sure, why not? When in Rome. I think that's actually my headset though, so I really don't think that's going to do anything. So press Control and C to exit. Oh, nope, just getting a hassle there in general. So I'll go back here. I'm going to disconnect my USB and try plug it into a different one. So that's plugging into a different one. Now it's refreshed. I'll actually just close it and open again to make sure it's properly refreshed. Device manager. Ports and COM port 4. So let's do that. Hey, there we go. So I don't know what was wrong with the other port. That happens. Oh, look, all this data is looking real weird. What's going on? It should say light, but saying look. So actually, I've noticed this problem, and I Googled it. If you have makecode.org open in the background, it seems to screw up. So I'm just going to close this. And now after, hey, look, all my data looks real nice and neat, except for obviously all this junk. So the next thing I'm going to do is going to clean up that junk and get rid of the stuff we don't need. But you will notice that light and temperature are coming in as full words, unlike earlier where they were coming in. Actually, let's stop that. Where they're coming in all screwed up. There we go. So up here they were screwed up, LIG without the T, TUMP, and all that jazz. Now the next thing we need to do is clean up this data. So that'll be our next step. Okay, so next we want to just do a little clean of the data. So I'm going to add in a line here. Now there's a few various ways, but we're using the replace function basically. And what I'm going to do first is I'm just going to tell it to cut and only pick up certain parts of the string. So if you take a look down here at the string, for example, I don't need, the first seems to be a B and then that. So I'm going to cut 0 and 1, index 0 and index 1. So I'm going to start at 2, which should be the first letter. And I'm going to take it to, well, it seems like there's a big long gap that I can take, but I'm just going to say up to 6. Could even go a bit further actually. Let's see, 2, 3, 4, 5. Actually, I probably need a bit more. So I'll say up to 10, right? But you can play around with this. And I'm going to replace any space here, any space with no space. So let's just try run this now and see what happens. So it seems to be recording the light and temperature. Now I need to test the light. So I'm going to put my torch back on to make sure it's actually recording correctly. And you can see, now I've got my torch on fully and it's only recording light up to like 22, which I'm guessing means that I probably need to control and see this and then make this bigger. So I might just go up to, probably 11 is probably enough, but I'll go up to 14. Let's see what happens. So now when I run it, temperature 22, light 0. Now I'm going to shine my light on, and now I seem to be getting the full measurement of light here, 239, nice big numbers where it should be when I had the light on it. And it's back to 0 because I'm just, every time I'm taking the light off. Okay, so that's how we can clean our data nice and simply in one line. Just say measurement is now just the index, we're doing a string slicing, and then we're replacing any empty space with nothing. So that is your step for cleaning the data. Okay, now that we've cleaned our data, we're going to have to start collecting it. So we're wanting to collect it, but we also have to realize we have two pieces of data. We've got light and temperature. So the first thing I'm going to do is actually make a little statement. Now I'm going to be a bit cheeky here and say, okay, if the string temp is in measurement, then I want to do what I had previously done. I will get, measurement equals measurement, so I clean it up, that's fine. And I'm going to add in another bit to that. I'm going to say temp is equal to measurement, and I'm going to do another replace, but this time I'm going to replace temp with nothing. So I'm now just sending no data, or sorry, no data, hopefully sending just the number, but without the TEMP part. I don't need to print it, so I'm just gonna get rid of that. So if it has temperature and measurement, do that. Don't forget our colon. And then else, if it has light in it, I'm gonna do the opposite. Or you can just leave it as an else. I'll do it as an elif. Sure, why not? When in Rome. So if light and measurement, and this time I'm gonna make a new variable called light, and I'm gonna say replace light. Oops, 1, 2, 3, 4. Light with that. Now, I've ran this before and checked it, and it sometimes gives an error because it might do the first measurement, and the first measurement might be light, so it skips and then it's going to break. So what I'm going to do up here very cheekily is just put in that temp equals 22 and light equals 0. Now, the thing about this is you're going to be collecting so much data that 1 or 2 data points wrong doesn't really matter. So I'm just putting it as if I start it in darkness and then the temperature is room temperature. So now we've got it identifying between the 2 differences, and now we need to save it to a CSV file. So I'm going to just drop a whole bunch of code here. Here we go. Make sure it's in line with your in the while true statement. So what we're going to do is we're going to read the measurement, the string. We're going to identify it's a temperature or light. Then we're going to open our CSV file. So microcollect, I called it .csv. You call it whatever you want. And we're going to append the existing file on a new line. And what we're going to do is we're going to append. This is just basically writing the data. This is just shortening CSV writer F to be just CSV. ZSV here. Right row. So we're going to right row temperature and light. So my first column is going to be temperature and my second column is going to be light, and then it's going to close each time. It'll reopen each time and close each time there's a measurement taken. Now, what I'll say is technically it's going to keep the value from the previous one. Let's say temperature is 22 and it's going to add the new light, and then the next time it'll keep the same light and add the new temperature. Now, if you want to get more accuracy with this, then you could just shorten the wait statement that we had initially in the makecode.org. Oh, I closed that, but you get the idea. So, right, let's just run this and see what happens. Now, when I run it, nothing seems to happen. So what I'm going to do is I'm going to press Control and C to safely exit. There it goes. It's closed now. I'm going to minimize this, and where I've saved, just check that. If you can't find the file, just check where you saved it. So save as. I saved mine to my desktop. Okay. So on your desktop, you should find the file, microcollect. And here it is. Sure enough, there's the temperature column, and there's the light. I'm just going to test it now. I'm actually going to delete all these because I've done it before. And I'm going to try run it again. Yes, I'll save it. Or actually, Joe, I'll even go one step further. I'll cancel and I'll just delete the whole file. Don't save. And delete the whole file. So now in my Thonny, when I run it, I'm running the program now. I'm going to get my torch and I'm shining it over my Microbit right now. And it'll take a little bit of time. Diddly ding ding ding, because I want to get a few different measurements. Light close and far away. Okay. And I close my serial connection. Control and C. And now on my desktop, sure enough, the file is back. Open it up. And there we can see it's collecting temperature and it's collecting the range of light. So if you want to get more data in that time, all you need to do is go back to your original make code and shorten. I put a 1 second wait between each of them. So just shorten that, make it less, and you'll get more data collected in there. So that's how we separate it into the 2 data types and save both into our CSV file. Okay, last thing we're going to want to do is analyze the data and collect some statistics from it. So firstly, I'm going to go in and I'm going to import both pandas and statistics. Now, actually, I didn't emphasize this last time. I'd imported CSV. Sorry, I've done it in the background there. So obviously, if you got an error about CSV missing, you need to import. If you're missing any of these modules, just go to Tools, Manage Packages, and type in the one you want to find. So for example, if it's pandas, I go Find Package, and I install the latest one. Now I've already installed it, and statistics as well. So down here, I'm going to do the following. I'm going to first create a nice little pandas table of data. So this is going to tabulate it. Now I'm just going to drop everything in here and talk through it. So this all is after we've closed our serial connection. So this is basically when we're done. We're then going to run this part of the program because we're basically going to have all our data and now we're analyzing it. So our column names, right? Our column names are not measurements. They are, I think I said temp and light. Now you can I'm going to call it capital temp, comma, capital light. I'm going to read the data file. This data file I used was called microcollect, so I make sure to change this to microcollect. And I'm going to say names is column names, which is the bit that I put here. So basically it's identifying that the left-hand column is temperature and the next column is light. Okay. Turn the given column into a list. So I'm going to turn this measurement dot to list. So that is not what I want here. I want to say, let's just do temperature first. So I'm going to turn temperature CSV. So I'm making a new thing called temperature CSV, and I'm going to turn the temperature stuff, all these numbers, which is the number 23 and 22, into a list. And then I could find the mean, median, mode of these. So all I do is statistics mean, and then I say here temperature.csv or temperature_CSV. So I'm just going to copy paste that. It's very exciting watching someone copy paste. There we go. And what should happen here is if I run my program. Okay, so, oh, sorry, it gave a good error to get, right? Gave an error, permission denied, right? Go up to here. I have the Excel file open, just close it. And now when you run it, now just check, it might have screwed up your file. No, it didn't, Grant. So just go here and run it again. Basically, you can't access it while it's while you have the file open. So I'm just going to shine some light on this again for a few seconds and let it collect a bit more data. And I'm going to close. Control and C to safely close. Data frame object with no attribute temp. So here I have gone for lowercase temp, but I called the column names uppercase. So good mistake. So let me just fix these up here. Now this is lowercase temp, so that's fine to leave here. Let's run this again. I should have data already, so I'm going to press Control and C. And hey, mean measurement 22, median 23, and mode 23, which kind of makes sense for the temperature. So I can rinse and repeat this for light. So I can just copy paste this and do it for light. Making sure to put capital light here because I'm reading the column. And then copy paste these things. And change all of these to light CSV. There we go. Now when I run it, safely exit, and there we go. I've got mode median measurement for my light, and I've got it for my temperature as well. Obviously, I'm going to put in some words here to make this nicer and neater, but I'll do that off screen. Okay, now that we have all our statistics of our data and stuff, we might want to do some graphing. So the first thing we're going to do is go up to the top here, and we're going to import numpy and matplotlib. So basically what numpy and matplotlib are doing is numpy is it's for scientific computing, and this is for plotting graphs. So you kind of generally need these guys hand in hand. So what I'm going to do is I'm going to go for let's just go for a bar chart. Now the thing you can do, I'll just get it open up here, there we go, is you can go to W3 Schools and you can look up matplotlib and get a whole tutorial of different stuff. So there's obviously scatter plots, there's bar charts, there's histograms, there's pie charts, there's whatever you want, right? I'm going to go for bar charts, and you can obviously steal this and just run it directly. I'll just use one that I kind of played with earlier in a previous code. So here, first this is just creating the figure size, right? That's fine. You can play around with that yourself. I'm assuming that's the X and that's the Y. Here, plot the parts. So I'm going to plot from our given column into a list. This stuff is what we're plotting. So I'm going to plot my temp CSV in my X, and I'll plot my light CSV in my Y. So it goes X, Y, the color you want. I'm going to go for hot pink. You can also look on, probably just type in colors and you'll probably find what you want. And the width of each bar chart, you can play around with this. I'm going to go for 0.2. Adding the X labels. Well, my X I said was temp, so I'll go temp. My Y here is light, so I'll change this to light. And my title I'll go is light versus temp. Now for my data that we've collected, I'm going to guess that this will make an absolutely garbage bar chart. But let's just go. Plot.show is to present the graph. So run your program. It's collecting data. we already have data collected, so I'm just going to press Control and C. And sure enough, there we go. It's collected 2 bars. Now, what's going on here? Well, look, 0 was an answer that happened a lot for light, if we remember. So a lot of our answers are just down here at 0, which is why we can't see them. We only had 22 and 23 for our temp, so it's not going to be great. But fundamentally, that's it for doing a bar chart. Now, if you want to play around, you could whip this open and grab yourself a scatter plot, okay, which might be a bit nicer for doing. And you probably get something that looks more like this. The idea is the same idea. I'm just going to steal here this line of plot scatter. So if I go dink, plot scatter XY instead of plot bar. So I'll just actually drop that up here. Let me get rid of that. And let me just put a hashtag on that and just see how we're getting on here. Yeah, I'd say that should be fine, except I probably need to tell it temp CSV for X. Oopsie. And light CSV for Y, because it needs to know where it's getting this data from. And yeah, let's just see what happens there. Run. End it. And hey, there you go. With 2 minutes of playing with it, not really sure what I was doing, managed to figure it out. And you can see here it's plotted temperature versus light. Now this obviously, again, not good data because they are unrelated here. I just had the temperature of the room, which wasn't changing, and I had a light where I was putting it on and off. So this might be something done better with, say, if you were somehow having it related to maybe the temperature of a lamp that it was near, and it was also changing the temperature as well as the light. And you might need to use probably not the built-in temperature sensor. You probably need to use a more sensitive one for that. Anyway, that's the basics of how to get some graphing. The key thing I'll bring your attention to is W3 School's tutorials on Matplotlib. If you just Google it, you'll find it. You can see there's an NUMPY NumPy thing, numerical Python, as well, that you can knock yourself out having a great time. But the key thing here is really just to get it up and working for yourself. So try a few different ways that you might decide to plot it, whatever's most relevant to your project.